Hello everyone, I am Sharan. In this video, we are going to discuss the first chapter of 10th class, that is real numbers. Okay, let us discuss some basics regarding this chapter. So first, natural numbers. So the numbers from 1 to infinity are said to be the natural numbers denoted by n. Okay, so the numbers from 1 to infinity are said to be natural numbers. For example, 1, 2, 3, 4, 5, 6, so on numbers are said to be the natural numbers. Next, whole numbers. So whole numbers are denoted by W. Okay, so the numbers from 0 to infinity are said to be the whole numbers. So for example, 0, 1, 2, 3, 4, so on numbers are said to be the whole numbers. Next, integers. Okay, so integers are denoted by Z. Okay, so minus infinity to plus infinity are said to be the integers. So negative numbers and positive numbers including 0. For example, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, so on numbers are said to be the integers. So here negative numbers, minus infinity and plus infinity, positive numbers including 0. So these numbers are said to be the integers. Okay, so next, rational numbers. So rational numbers are denoted by Q. Okay, so the numbers which are in the form of P by Q. Okay, so that means it must be in the fraction form. Okay, so numbers which are in the form of P by Q, where Q not equal to 0. So that means denominator must be not equal to 0 here. So for example, 3 by 5. So here 3 is the numerator and 5 is the denominator. Okay, and denominator is not equal to 0. So 3 by 5, it is a rational number. It is of the form P by Q. So therefore it is a rational number. And for example, 2 by 3 and 0.333, so on. It is also a rational number. See, 0.33, it can be written as 1 by 3. Okay, so 0.33 bar, 3 bar, it can be written as 1 by 3. So 1 by 3, that means numerator is 1 and denominator is 3 here. So it is also a rational number. So next, irrational numbers. Rational number. Okay, so irrational numbers are denoted by Q dash. So the numbers which are not in the form of P by Q, so those numbers are said to be the irrational numbers. That means it cannot be expressed in the fraction. Okay, so irrational means, so it's not rational. Okay, so it is not rational. So here the decimal expansion goes on forever without repeating. Okay, so for example, so pi. Okay, so pi value is 3.1415, so on. Okay, so its value is 3.1415, so on. Okay, so actually we are taking pi value as 22 by 7 in some problems. Okay, so 22 by 7 is the only approximation value of pi. So actually the pi value is 3.1415, so on. Okay, so here 22 by 7 means its value 3.142 something. Okay, so that means only here to 3.1415, so on. That means the decimal value is goes forever without repeating. Okay, so this 22 by 7 is only the approximation value. So other examples of the irrational numbers are root 2, root 3, root 7 and root 6. Okay, so root 11. Okay, and root 4 is not a irrational number, since root 4 is the perfect square number. So perfect square numbers are not irrational, since so root 4 value is 2. So we can write it as 2 by 1. So it is of the P by Q form. So P is the 2 and Q is the 1. Okay, so numerator is 2 and denominator is 1. So it is a rational number. So perfect square numbers are not the irrational numbers. So only those numbers which are not perfect square, so those are irrational numbers. Next, prime numbers. Okay, so prime numbers are the numbers which are divisible by 1 and itself. Okay, so numbers divisible by 1 and itself. 1 and itself. Those numbers are said to be the prime numbers. So for example, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47. Okay, next 53, 59, okay, 61 and 67, 71, 73, 79. So 83, 89 and 97. So these are the prime numbers. So if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So 25 primes. Okay. So 25 prime numbers are there between 1 and 100. Okay. So from 1 to 100 there are 75 primes. So out of this 2 is the smallest prime. So 2 is the smallest prime number and it is the only even prime number. Okay. And is only the even prime number. And remaining all are the odd numbers here. Okay. So only 2 is the even prime number and it is the smallest prime number. And 97 is the greatest 2-digit prime number. Okay. So largest or greatest 2-digit prime number. Greatest 2-digit prime is 97. Okay. So prime numbers are the numbers which are divisible by 1 and so number 1 and number itself. Okay. So for example, if we take 2. Okay. So here 2 is divisible by 1 table. 1 2 is a 2 and 2 table. 2 1 is a 2. So this 2 is divisible by 1 and number itself. Okay. So it is divisible by 1 and number itself. So again for example, if we take as 7. Okay. So 7 is divisible by 1 table. Okay. 1 7 is 7. Again it is divisible by 7 table itself. That means 7 1 is 7. Okay. So here 7 is divisible by 1 and number itself. So it is said to be the prime number. So for example, if we take as 6. Okay. So here 6 is 1 6 is 6 and 2 3 is 6. 3 2 is 6 and 6 1 is 6. Okay. So here 6 is divisible by 1 and number itself and 2 and 3 also it is divisible by other two numbers. Okay. So therefore it is said to be not a prime number. Okay. So the numbers which are not prime, those are said to be the composite numbers. Okay. So composite numbers. So the numbers which are not prime. So those numbers are said to be the composite numbers. So for example, 4, 6, 8, 9, okay, so on. So the numbers which are not prime, those are said to be the composite numbers. So if you observe here, so 1 is not present in prime number and not in the composite number. So 1 is neither prime nor composite. Okay. So 1 is neither prime nor a composite. So it is not a prime number, it is not a composite number. Okay. So again next, twin primes. So twin primes are the prime numbers which are differ by 2. Those are said to be the twin primes. So for example, if we take 3 and 5. Okay. So 3 comma 5. So here 5 minus 3 is 2. So therefore the difference of the two prime numbers is 2. Therefore these two are said to be the twin primes. Okay. So numbers, prime numbers which are differ by 2. Prime numbers differ by 2 are said to be the twin primes. So again 5 comma 7. So it is also a twin prime since 7 minus 5 is 2. Similarly 29 comma 31. Okay. So 29 comma 31. Since 31 minus 29 is 2. The difference of 31 and 29 is 2. Therefore 29 comma 31 is a twin prime. Okay. Next, co-primes. Okay. So co-primes. So co-primes is the SCF of, if the SCF of two numbers is 1, then they are said to be the co-primes. Okay. If SCF of two numbers is 1, they are said to be the co-primes. So for example 2 comma 3. Okay. So 2 comma 3 here SCF of 2 and 3 is, so if you do SCF here, so larger number is taken as the dividend and smaller number as the divisor. Okay. So 2 1 is 2, remainder is 1. Again this 2 comes here. 1 2 is 2, so remainder is 0. So SCF of 2 and 3 is 1 we have obtained. Okay. So SCF of 2 and 3 is 1. Therefore these two are the co-primes. Similarly 4 comma 5. Okay. SCF of 4 and 5. 4 1 is 4, remainder is 1. Again 4 1 4 is 4, remainder is 0. So SCF you have obtained is 1. Therefore SCF of 4 comma 5 is 1. These two are said to be the co-primes. So if you observe here, so 4 is a composite number, 5 is a prime number, but the SCF of the two numbers is a 1. Okay, so since the SCF of the two numbers is we have obtained 1, therefore these two numbers are said to be the co-primes. Okay, so next real numbers. Okay, so real numbers are, so all the numbers, natural numbers, whole numbers, integers, rational, irrational, so all the numbers are belongs to the real numbers. Okay, so for example, so natural number is subset of whole number. Okay, and whole number is subset of integers. Okay, so integer is a subset of rational number. Okay, so q dash is the irrational number. So real number is the universal set, that means it consisting of all the rational number and irrational number. So therefore real number can also be defined as, so union of rational and irrational. So R equal to q union q dash, it can also be written as union of rational number and irrational number. Okay, so real numbers is not the imaginary, the numbers which are not imaginary, those are said to be the real numbers. Okay, so for example, imaginary numbers like under root of -1, so these are not real since they are imaginary numbers, and infinity is also not the real number. Next, Euclid division algorithm. Euclid division algorithm. Okay, the Euclid division algorithm or Euclid division lemmas. Okay, so here the statement is, so given positive integers a and b, a and b. Okay, so there exists unique pair of integers. There exists unique pair of integers q and r satisfying the condition a equal to bq plus r, a 0 less than or equal to r less than b. Okay, so this is the theorem statement. Okay, so we know the division algorithm is dividend equal to divisor into quotient plus remainder. Okay, so dividend equal to divisor into quotient plus remainder. Okay, so here a is the dividend. Okay, so b is the divisor. Okay, and q is the quotient, r is the remainder. Okay, so 0 less than or equal to r, so here condition is 0 less than or equal to r, and r less than b. Okay, so 0 less than or equal to r, that means 0 less than r, or it may be 0 equal to r. Okay, so that means r value may be greater than 0 or r value may be equal to 0, and r value is always less than b. Okay, so remainder value is always less than the divisor. Okay, so if we take for example 16 divided by 3. Okay, so 16 divided by 3, that means 3 5 is 15, remainder is 1. So here dividend, so dividend is 16. Okay, equal to, okay, dividend equal to divisor into quotient, so bq, so b is 3. Okay, 3 into 5 plus remainder is 1. Okay, so a equal to bq plus r, it is of the form a equal to bq plus r. So here dividend equal to divisor into quotient plus remainder we have obtained. So 3 5 is 15, 15 plus 1 is 16. So we are getting the dividend here. Okay, so here remainder is 1. Okay, so r value is 1, that means remainder equal to 1. So 0 less than r, so 0 less than r, that means 0 is less than here 1. So we are obtaining 0 is less than 1, and r less than b. Okay, so r less than b, that means r value is here 1. Okay, so r less than b, so that means 1 less than, so b value is here 3. Okay, so 1 less than b. So this is satisfying the condition 0 less than or equal to r less than b. Okay, so it is satisfying the condition 0 less than r less than b. Okay, so suppose if we take another example 15 by 3. Okay, so 15 by 3, that means 3 5 is 15, so remainder is 0. Okay, so here dividend is 15 equal to divisor is 3. Okay, into quotient is 5 plus remainder is 0. Okay, so a equal to bq plus r, it is of the form a equal to bq plus r, 3 5 is 15. Okay, 15 plus 0 is 15. Okay, so here dividend equal to, we have obtained divisor into quotient plus remainder. Okay, so here remainder value is 0. Okay, so 0 less than or equal to r. That means 0 may be less than or 0 equal to r. Here remainder equal to 0. That means so the r value equal to 0. Okay, and r less than b. So r less than b, that means so remainder here we have obtained is 0. So 0 less than, here b is 3. Okay, so it is satisfying the condition 0 equal to r less than b. Okay, so the condition is 0 less than r less than b from the first. Okay, from the second we have obtained 0 equal to r less than b. So from both we can write 0 less than or equal to r less than b. So this is the condition of Euclid division algorithm. And so if we observe here, so here remainder is 0. So that means this 15 is divisible by 3. So in case of 16 here, remainder is 1. That means 16 is not divisible by 3. So when the remainder is 0, so the dividend is said to be exactly divisible by the divisor. Okay, so here only 15 is divisible by 3 but not 16 since the remainder is 1. So this is all about the Euclid division algorithm.